So in this video, we will discuss how to use the floating point representation to perform some arithmetic calculation. So for example, we try to find the sum of 12 and 1.25 using the 14-bit simple floating point model we just discussed before. The first step is that we need to transform 12 into binary representation of the using the 14-bit simple floating point model. So basically, this is the normalized part, and also this is the exponent part. Also, we need to transform 1.25 into the way we the binary representation. So this one is a normalization part, and this one is the exponent part. Okay, so in order to do the sum, so we want to have the same exponent part of the both number. So we want to have this number also have the 2 power 4. Okay, so we're gonna shift the point right here to the left hand side for three points, 3 digit. Okay, so we can have this 1.25 can be represented by this string times 2 power 4. So once we have the two number have the same exponent part, we just put the exponent representation into this part. So this we use access 15. So basically 4 plus 15 equal 19. So this the binary string represent the value of 19. The same for the second number right here. Both of them have the positive value. So we have the sign equals 0. And the significant part we just put right here. This is 1 0 1 0 0 1 1 0 0, and the remaining part gonna be equal 0. Also, we have the point right here. That's the binary point, and the this part gonna be copied to the significant of the second part. So in order to do the summation of both numbers, so we just copy the exponent part right here to the result. The sign gonna be 0, and the significant, we just add them up the same way we do the binary addition. So we have the 0 0 0 0 0 0 1 equal 1, 0 0 equals 0, and so on. Okay, so this is the how we do the addition using the floating point representation. The floating point multiplication is also carried out in a manner akin to how we perform multiplication using the pencil paper. So basically, we multiply two operand, and also we add their exponents. If the exponent require adjustment, we do so at the end of the calculation. So now we show how to use a floating point representation to do the multiplication of two numbers. So for example, we try to find the product of 12 and 1.25 using a 14-bit floating point model. So the same as before, the first step we will represent 12 in the standard normalized form of the 14-bit floating point model. So that's 0.110 times 2 power 4. And we also represent 1.25 in the normalized form, and that's 0.101 times 2 power 1. Okay, so in order to do the multiplication of two numbers, the exponent is just times with each other. So basically 2 power 4 times 2 power 1 equals 2 power 5. That's the 4 plus 1, okay, equal to 2 power 5. And the significant gonna do the multiplication as the same. So this is 1 1 0 0 times with 1 0 1 0. Okay, so that we get the significant part right here. So once we get the significant part right here, we need to transform back into the normalization form. So basically we shift the binary point right here from this point to this point. So it means we time with two -1, we time with 2 power 5, so -1 and 5 gonna get the 2 power 4. Okay, so this is the normalization form, and then the result will gonna be represented in this form. So we can see that 2 power 4 basically a add with 15 because it access 15 representation. So we have 19 represented by this binary string. So this one gonna be the exponent part right here. The sign equal to 0 because two numbers are positive time multiply with each other, gonna get the positive sign, and the remaining part right here, that's a significant, gonna be copy this string down here. Okay, the remaining bit right here is just part 0e. So that's show how to perform the multiplication of two numbers using floating point representation. Especially we use the 14-bit floating point model in this example.